Good afternoon all. I thank the organizing committee for giving me the opportunity for chairing this session. So, gut is described as the second brain. The enteric nervous system acts independent of the central nervous system, and it influences our mood, our behavior, and even our cognitive facilities. And the basis of the enteric nervous system is this gut flora. And any changes in the gut flora will result in various metabolic disturbances and many diseases of the abdomen. With this, I invite Dr. Vetrivel from Vellore. He is an eminent physician and he is going to talk on this topic.
Good afternoon, everybody. Respected chairperson, my affectionate seniors and colleagues and others. It gives me immense pleasure to be with you in this afternoon to talk on a rare subject which is budding now. I owe this topic to my mentor, Dr. Samji Moses and Dr. S.K. Rajan sir. At the outset, I thank profusely the organizing committee of TRAC 25. You know, this chapter which is going to deal with the gut microbiota and its imbalance with the most prevalent diabetic scenario in the world. Type 2 diabetes is a common metabolic disorder, you all know, characterized by insulin resistance and pancreatic cell dysfunction. Emerging evidence suggests there is a link between imbalance of the gut microbiota and the ongoing process of metabolic milieu in diabetic arena. Gut dysbiosis is an imbalance in the gut microbial ecosystem, which is dense and diverse, increasingly recognized as a crucial factor in the development and progression of this disorder. Changes in the composition of gut microbiota can affect metabolism, inflammation, and integrity of intestinal barrier, potentially contributing to less insulin secretion, insulin resistance, and other diabetic-related matters. See, diabetes has reached epidemic proportion, but there are so much of, fuss is attached with who is maintaining HbA1c less than 7. So we are searching for a new avenues for that. Studies have shown that gut inflammation, compromised gut permeability, impaired glucose homeostasis, lipid metabolism, insulin sensitivity, increased fatty acid oxidation, and interaction with the dietary components are the mainstay of this talk. There is clear growing evidence that a close relationship between these two is there, and it's of worthy of future investment and research efforts, because this topic, whenever we talk in forum, it is undermined and overlooked. In a research I have found that the Indian guts have been damaged much due to the unwanted lifestyle measures, including the blunderbuss dietary schedule, and creating a lot of raft of disease condition, both physical and psychological. We have to salute our forefather Hippocrates, who said 2.5 millennium back, all disease begins in the gut. Health is written by gut microbiota. Death sits in the bowl. A bad digestion is the root cause of evil. After this 2.5 millennium, we just now starting to recognize the importance of it, and we are the doorstep opening the important vista. This gut microbiome, the science is exploding like anything. We carry 2 kg of a suitcase in our gut. People are sampling their own stools for the process of science and taking lot of probiotics in the form of yogurt, kombucha and kimchi, and try to foster good health. The science is exploding like anything, but we are just at the gate of it, as I told you. This hidden forgotten organ, which is the allobionant, is having nearly about 100 trillion microbes comprising of bacteria, virus, archaea, and the fungi. 3 million genes are there. Almost these species control all bodily functions. What are they? Before that, one has to differentiate between what is microbiome, what is microbiota. Microbiota is the organism itself. Microbiome comprises of organism and the genes, genomics, and the living environment, biome, and the theatre of activity, that the metabolites which are called as postbiotics. So all the four comprising of microbiome. So in our gut, we have got four classes of microbiota. What are they? Firmicutes, Actinobacter, Bacteroides, Proteobacter. Each one imparts their function whenever they are healthy or whenever unhealthy. See, Firmicutes, which is the major portion, 47%, comprises of Lactobacillus, Roseburia, Clostridium, Picalibacterium, and others. In Bacteroides, we have got Pravitella and Alistipsis, and in the Proteobacter sector, we have got so much of Klebsiella, Pseudomonas, etc., which are gram-negative. In Actinobacter, we have got potentially good Bifidobacterium, Actinomyces, etc., and in this side, we have got the Akkermansia, Mucinapilli, and Saccharomyces boulardii, which is a fungus. So, what are the various functions it performs? It performs immunomodulation. It performs preservation of epithelial intestinal integrity, and it prevents pathogen by secreting various metabolites like defensin, bactericin, etc. Not only that, it modifies the neurodevelopmental neurodegeneration, and it not only that, it helps for digestion and the metabolism of drugs, food, and xenobiotics. And also it is useful for biosynthesis of vitamins. We all know about that. But the pity is that modern civilization pay that there are a lot of modulation factors like diet. Diet is the crucial factor. Whatever we eat, that's not going to preserve the good bacteria. It is going to create an imbalance, which we'll see. Then drugs like antibiotics, proton pump inhibitors, statins, steroids, geographical location, life stages, what the children is having, they are not be possessed by elderly people. And birthing process, when the cesarean section, no good bacteria, dense bacteria or diverse bacteria. In normal delivery, there's a lot of good bacteria is acquired by the infant. So the feeding, the milking process, the lactation process, milk-fed babies, breastfed babies are having good bacteria, whereas the bottle-fed is not having good bacteria. We are subject to much stress, psychological, metabolic, etc., which these are the factors which modulate and produces imbalance in this. So gut biosis, the normal flora, when it's disturbed, we call it a dysbiosis. An imbalance in the between commensal and pathogen is known as gut dysbiosis, which lead to various diseases comprising of cardiometabolic, gastrointestinal, and neural, and pulmonary, and skin, etc. In this, we will be discussing about the important metabolic condition known as diabetes mellitus. See, gut dysbiosis in DM, decreased abundance of beneficial bacteria like Picalibacterium prausnitzii, Roseburia industrialis, Roseburia insulinivorus, and Akkermansia mucinaphila. These are the important bacteria which cannot be disturbed. But in the diabetes, it is disturbed. Shift in the ratio of Firmicutes and Bacteroides, a decrease in the short chain fatty acid producing organism, which will be important for prevention of leaky gut syndrome, which we will be alluding to, and it's going to impair the intestinal epithelial barrier integrity. The leaky gut syndrome allows certain things which we will be seeing, which is going to put havoc and create finally inflammatory state, insulin resistance. Metabolic changes like a reduced short chain fatty acids production impacting glucose metabolism, insulin sensitivity, barrier function as I told you, then altering the bile acid profile, altering the branch chain amino acids, aromatic amino acids, and creating havoc. In addition to this, the pathogens producing TMA, trimethyl alanine nitrous oxide, and the branch side amino acids, and all are going to impact on the insulin resistance and produces finally CV risk. So these are this table depicts the decrease and increase which was discussed in detail. Gut microbiota in the pathogenesis and therapeutic approaches in diabetes is well dealt. between 1995 up to 2005, there were about 9,000 papers released in the leading journals, but still the knowledge here in India is in the rudimentary stage. Now only we are making it, we will see. Bacterium like Bifidobacterium, Lactobacillus, Clostridia certain specimens, group comprising of the gut microbiota complex, they are digesting non-digestible carbohydrates found in the dietary fibers, producing short-chain fatty acids. These short-chain fatty acids going to get the expression of G protein coupled receptors 41, 43 and 10A on L cells of the intestine, which will be emanating GLP, endogenous GLP-1 and P peptide, PWI, and decrease the PPR gamma activity, which enhances oxidative metabolism in the liver and adipose tissue, decrease the fat accumulation, mitigating the fat accumulation, thereby the lipotoxicity is reduced. When the lipotoxicity is reduced, there is an absence of cetramide, the triacylglycerol and diacylglycerol, which will clear a good liver function, though the insulin sensitivity will be more. Insulin resistance is not there. So this GLP-1 polypeptide WI decreases appetite and prolongs the gastric emptying, increases the peristalsis, and insulin sensitivity increase, insulin secretion increase, beta cell apoptosis prevented, and there is a lot of beta cell regeneration and good amount of beta cell function. So butyrate promotes the expression of tight junction. You know, butyrate is also one of the short-chain fatty acid. It promotes the expression of tight junction proteins, occludin, zona occludins and singulins, etc. And they will produce more expression of mucus secreting goblet cells. So thick mucus is produced, and they will close the gate of the junctions, which is guarded by these proteins, and prevents leaky gut syndrome. So butyrate, not only that, because of certain action on the epithelial integrity, prevents the entry exit of LPS, which we lipopolysaccharide, which is an endotoxin, will be alluding to, which will be cause for the emanation of cytokines and chemokines and lipokines, especially IL-6, tumor necrosis factor alpha, thereby producing inflammatory milieu and increased insulin resistance, which is prevented by this short-chain fatty acids, butyrate. When short-chain fatty acids meet type 2 diabetes, short-chain fatty acids not only produces the expression of the protein coupled receptors on the L cell, producing more GLP-1 and WI, they will be producing more amount of beta cell function and prevents the formation of LPS. You know, whenever there is a gram-negative bacteria is more in the intestine, you could understand the wall of the gram-negative bacteria secretes LPS, lipopolysaccharide, which is an endotoxin. This LPS, when it expressed on the toll-like receptors 2 and 4, which are transmembrane receptors, they kindle the endocannabinoid system 1 and 2, traverse through the junction, and when the endotoxin traverse through the junction and enters the circulation, there is a condition known as metabolic endotoxemia. This metabolic endotoxemia is a root cause for pro-inflammatory state, which will be producing abundant amount of insulin resistance, thereby producing this thing, diabetes mellitus. These are the thing. Secondary thing, the common salts are protection against conversion of bile acids to secondary bile acid, and prevention of the disposal of the emanation of branch-chain amino acids, aromatic amino acids. So these two processes will be prevented by common salts, which are stimulated by the production of the branch-chain amino acids, aromatic amino acids, which are caused for intestinal dysbiosis, decreased butyrate secreting organisms,